Hi everyone, it's Mr. Swan. I'm really sorry that I can't be there today on our first lesson, but unfortunately I was picking up a bit of a fever, mild fever, over the weekend, and the doctor came to the house last night and said it would be best if I don't go to work, as I'm a little contagious still. So here I am. I'm going to be giving you guys a brief overview of the slideshow that's been prepared for you today. And in order to work through this together while you're watching this video, what I'd like you to do is just go ahead and create a Google Doc, which are going to be kind of your notes for today. And you can label those notes exactly as you see here on the title screen, 1.3, Scale, Duration, Frequency, and Variability of Hazards. And as you can see, our objective for today is to be able to describe what scale is, what duration is, what frequency is, and variability within the context of hazards, but also disasters. And we have a little starter here. So what we're going to do is I'm going to ask you to kind of work through this individually today in class. And whenever you see a Think, Pair, Share slide, I'd like you to just do that activity on your own in your Google Notes for now. When I arrive back at school, we can go ahead and go through those Think, Pair, Shares and just have a brief discussion about what it is that you were able to determine. Okay, so for our starter, what I'd like you to do is just go ahead and write down what you think scale, duration, frequency, and variability might mean in the context of hazards and disasters. So just take a moment and write down what you think those could be in your notes. If you like, what you can do is just number those, 1, 2, 3, 4, or you can bold them and give them separate headings on your page. But just take a minute or two and go ahead and write down what you think those words mean. And then pause this video. Okay, it seems like you're done. You've unpaused the video. So again, looking at scale, what we're really looking at here is how large a particular hazard or disaster is. Check to see if that reflects anything that you've written down. The duration refers to how long, which I think you've probably nailed down there. And the frequency is about how often those kinds of disasters occur. And the variability refers to kind of how much we can sort of predict these types of events. So again, we have our 4 terms, okay? And as we go through these next slides, I'm going to ask you to think about some questions with each of those. Okay, the first one is scale, and scale has 2 parts, effectively. The first part of scale, in other words, determining how large a particular event was actually looking at the physical size of that event. In other words, how large of an area did it actually impact? So for example, if we look at Lima in Peru, we'd be looking at a local example if there was a disaster or hazard just within the city center of Lima, let's say. If that expanded outwards into the mountains and into the neighboring districts of Peru and states of Peru, then that would be more of a regional issue. If it seemed to take up a large chunk of the country's area or impacted a large portion of the country, then it would be of national scale. And if the disaster flows into other countries, it impacts other countries as well, then obviously that would be an international disaster. So you probably are wondering, how could a disaster be so large that it would affect an entire country? And here's an example from 2010. In January of 2010, there was quite a large and very strong, I believe 7.0 earthquake in Haiti. Excuse me. Pardon me. And the event itself was actually quite devastating because the earthquake only took place, I believe, 7 kilometers underneath the surface of, almost directly under the capital, Port-au-Prince of Haiti. And as you can see here from the legend, We have the perceived shaking. So this is the amount of shaking that people felt. And you can see that obviously towards the center of that event, there was extreme shaking. And it almost spread into the entire country, that particular earthquake, in terms of what people could feel. There's other data to show that in terms of people affected and damage to neighboring cities, that actually across this entire area of yellow and green and orange, and in many cases of the blue, anywhere between 70 to 50% of the buildings were either damaged or destroyed in that area. And unfortunately, over 230,000 people died in that particular single earthquake alone. The next aspect of scale is the severity of that scale. In other words, how strong is it? So not the physical impact area, but how strong it actually is. Obviously in Peru, one of the largest things that we look for in terms of hazards and then potentially disasters is earthquakes. And earthquakes are measured according to an international scale called the Richter magnitude scale. And essentially every time you go up one number in the Richter scale, you increase the power of the earthquake by 10 times. And earthquakes are obviously something that we're very aware of here in Peru. And we do watch what kinds of earthquakes are happening in the local area on a regular basis. And we will take a look at that a little bit in just a moment in terms of where earthquakes are currently happening in the world. Obviously, there's other kinds of hazards too and disasters. Hong Kong, where I've just come from, is at risk of typhoons. And so it is a hazard. It's due to the warm air and warm water makeup of the Pacific Ocean, particularly along the equator. And with typhoons, cyclones, and hurricanes, which are all essentially the same thing, they're all the same kind of storm, just depends on where you're located in the world. In the case of typhoons, there actually isn't a common international scale used around the world. In some cases, countries have their own scales, and oftentimes these scales depend on which part of the world you're located in. So, for example, the Saffir-Simpson scale, which you see here, is really for hurricanes that take place in the Atlantic Ocean. But as you can see here, in terms of Hong Kong, they have their own classification system for how they measure the strength of those particular storms. So, for example, a Category 5 hurricane on the Saffir-Simpson scale needs to be sustained 1-minute winds for over 252 kilometers an hour, whereas in Hong Kong, it's measured differently at 185 kilometers per hour or above, sustained for 10 minutes, and that would be a super typhoon. So, while storms can be quite strong, they can be up above 252 kilometers per hour. Some scales just don't have additional levels to demonstrate how damaging that can be. What you can do now is just pause this video if you like, and you can watch this 2-minute clip on the latest major typhoon that went through Hong Kong. This was a typhoon that I was present in Hong Kong for, and can talk to you a little bit about my personal experience having been through that typhoon. But this was a super typhoon called Bangkut, and it was the largest storm of 2018 recorded anywhere in the world. And it did actually hit Hong Kong directly. Hong Kong is a very developed area. It has a lot of new buildings, and it's known for having a lot of skyscrapers and high-rise towers. I was living on the 50th floor of my building, for example. So I had a nice overview and could see a lot of the damage that took place, and I can show you some videos and pictures of my own later on. But this video comes from the South China Morning Post, gives you just a brief overview as to what that storm was like. So go ahead and pause this video, and then when you're done watching the South China Morning Post video here, you can come back and I'm going to ask you to answer some questions. Okay, so you've had a chance now to think a little bit about scale and you've seen a little bit about the severity and the size. So what I'd like you to do now, and again, this is initially a think, pair, share, but do it on your own. I'd like you to write down an answer to this question. And basically the question is, do you think that scale does not have a connection to or correlation to the severity of an event? Or does the scale actually determine the severity? So does the size, the overall area, as well as the strength, determine the severity of an event, or does it not determine that? Is there no connection? Okay, once you've had a chance to work through that, you can pause this video while you're doing it, come back, and then we'll look at duration. Okay, duration, as you probably guessed from before in our starter activity, is the amount of time in which a disaster is actually taking place, and it's also the amount of time between the time at which that disaster first happens and how long it takes for the life, if you will, the community at large, to come back to its kind of normal operating life, if you want to call it that. So functionality is restored. In other words, we have a functioning community, then we have a disaster, and then how long does it take in order for that community to become functioning again? Frequency is about the number of times in which a particular event happens. So for example, there's 3 different volcanic eruptions listed here. The first is Mount Vesuvius, which is very, very famous around the world. But typically, it doesn't erupt very often anymore. But until 1037, it did erupt about every 100 years. So it had a low frequency then, and actually today it's even lower. The next volcano, Nyiragongo, in the Democratic Republic of Congo, typically erupts every 4 years now. So scientists would say that this has a medium frequency. And then Stromboli is also in Italy, erupts quite regularly, maybe 2 or 3 times an hour. And so therefore it's listed as having a high frequency. So what I'd like you to do now is to just look at these wavelengths, and I'd like you to go ahead and just write down in your notes under frequency, what do you think is similar with those curves in terms of the frequency? So what do you see? What's the same? And pause this video and then write those things down. Unpause when you're ready to start. Okay, variability. So again, variability is about almost the predictability of a particular disaster. Obviously, Peru, for example, is located in an area with many fault lines, and because of the plate movements, we're expecting a lot of earthquakes here in Peru. The question is just, how often do those happen, and can those be predicted in some way? In other words, does the frequency allow us to kind of determine when the next large earthquake is going to take place? And the problem with this is that while there's typically broader patterns that can be perceived when it comes to events, it's very difficult to actually determine when a large event is going to take place. And so variability is something that we can't really, that actually poses a danger to us. We do try and predict these events, but we can't always be sure. And that's part of the problem with trying to support and help people leading up to these events, because oftentimes scientists will say that a particular event is going to take place and warn the local community, but then maybe that event doesn't take place, and the locals then don't react to it and think it's not an issue. And then when the scientists come along the next time and they warn the local community and say this could be an event, maybe the local community doesn't listen to them because nothing happened the last time. But then, just by chance, the event does happen, and it's very damaging. So variability is one of those issues that we're dealing with that is a problem for us. Right, so what I wanted to show you, as I mentioned before, is I wanted to show you the kind of the frequency, if you will, of the types of events that are happening in terms of earthquakes around the world. And this comes from the USGS, and you can click on the earthquakes today right there, and it will take you to the link that shows that map. But basically, what they do is they map out all of the worldwide earthquakes that are taking place. And when you click on this link, it was just going to show you the earthquakes that are happening today. And it's a live update. Typically, earthquakes of a 4.5 on the Richter scale can be felt anywhere in the world. So seismographs, say in Sweden, can actually pick up 4.5 earthquakes that take place in Peru, for example. That's how large they are. But here you can see the magnitude is represented by the size of the circle, and the age is represented by the color. So, for example, all of these are within the last day, and as I linked to the website, when I looked at that, I saw a earthquake in Costa Rica, I believe, that was within the last hour. And what you can do is, if you like, you can click on each of those earthquakes. So, for example, there was the Costa Rica 4.5, Queenstown 5.4, and it'll tell you just a little bit more information about, for example, when it occurred, how far away it was from a particular town, the severity, and so forth. So you can go ahead and explore that for a few minutes if you like, and then when you're ready, come back, and I'd like you to move on to the next slide. Okay, so for this particular slide, what I'd like you to do is, again, just working by yourself, I'd like you to think about what could be the particular kinds of connections that take place between scale, frequency, duration, and variability. Okay, what could be some common linking elements between each of those? All right, and when you're finished, I'd like you to go ahead and jump over to the worksheet, which is also in Google Classroom, and I'd like you to start working through those questions. And if you like, you can watch the video again and listen to it and help that guide you, or you can just look through the presentation. But I'd like you to go ahead and work on that independently today. And then, as I said, when I return, we'll go ahead and discuss what we were able to discover. Okay? So with that, again, just please go ahead and jump into that worksheet, and I'll have a submission post for Google Classroom, and we'll have that due prior to the next class. Okay, thanks everyone, and I hope you have a nice day. Bye-bye.